Okay, those who came late, I'll introduce myself. My name is Vinay. So I've been working in a data engineer field from 2+ years. So this fabric I've been working in like since past 2 years. So currently the fabric is in most of the companies they were using or they were migrating to fabric, which is restarted. So So today we are going to discuss about the introduction of a fabric, which is a unified uh, data analytics platform. So that is like, let's say we are using Python in VS Code or some other tools, PyCharm like that, and we store the data in SQL Server or some other platforms. So this Microsoft Fabric is like that all you can use in one platform, and you can write codes and you can store the data, and you can do machine learning models, and you can do visualizations, everything. And coming to uh, the agenda today is like what is Microsoft Fabric, and we also learn why we need to use Fabric, and also the core concepts of the Fabric, which are like only lakehouse, warehouse, and then notebooks, data pipelines, and all. And also the real time impact. How, like, I'll give an example of the retail uh, business, and then uh, at the end I'll walk through the Fabric UI, and then I will navigate how we can create lakehouse and warehouse, and how we can run the scripts. It is like similar to the Jupyter notebook. You guys aware of Jupyter notebook, right? So similar kind of thing, but it's little bit different, but the same thing we need to use. Um, and that's for the agenda. And also I'll explain the architecture flow, how the data flows from one step to another step. I mean, from data source to the insights, which is like share your screen. I'm sharing. And how the data flows from data source. You guys are aware of data source? What is data source? Sometimes it might be an web application. Like we need to extract the data. We need to extract the data from web application in forms of APIs, something like that. Or maybe they have the backend databases, which like SQL Server or Snowflake, something like that. So from that, those are called data sources. So from that, we need to extract the data, and then we'll load the data into lakehouse, and then we'll do medallion architecture, which is a raw layer, and then the transformations layer, and the goal layer, and which is aggregation tables. We'll build the aggregation tables. So I'll explain this in detail moving forward. So this is the flow of on Microsoft Fabric, the data flow of the Fabric, and based upon the gold tables or silver tables, like or the transformation data, we'll build Power BI dashboards or reports using the data, and then we'll create some insights or what do we call? If in case we need to predict something, we'll build ML models, and then we'll represent that data in Power BI reports. So that's the architecture flow of the Fabric, how we use. And coming to what is Fabric? Um, Fabric is a single uh, unified data analytics platform, which is like you can write a code and you can store the data. Nowadays, not nowadays, past they were using. Earlier I mentioned like Python in different tools, and SQL for storage purpose, different tools they were using, and BI different tool they were using. Now this Fabric is uh, very good innovation by Microsoft, and they come up with a good thing, which is a unified uh, platform to everyone. Like every organization can use it, and they can also build end-to-end pipeline solutions, and they can manipulate the data, and they can clean the data, they can transform the data, and they can build an insights using that data, and they can do whatever they need. So using this Fabric, what we can do is, so actually we can extract the data, as earlier I mentioned, so from different sources, which is web applications, and maybe some databases, or some other. Um, you guys know SFTP, maybe. No. So yeah, secure file transfer. Yeah, that's it. So we can extract the data from there. We can do web scraping as well. If we have a web application, if you don't have any APIs or something like that, you guys heard about APIs? Yeah. So if you don't have APIs on the web application, so we can do web scraping, which is uh, data scraping or web scraping, both are same. So we can use beautiful soup libraries, something like that. Selenium, I think, don't work in Fabric because we need to install some Chrome drivers in install some Chrome drivers, but that is not applicable for Fabric. So that those libraries won't work in Fabric. So there are some limitations, and then there are some advantages as well. So here, and why we need to use Fabric? Why we need to use Fabric is like, so in some organizations they have a different data sources or different data formats, like PDF formats and structured data and unstructured data, which is like PDF formats or CSV files, Excel files, or tables. So they can store everything in Lakehouse, and then they can access throughout the organization. Sometimes, let's say, salespeople can't. They don't know how the silver tables or transform tables will be look like, and they can go through only the PDF data or TXT files, something like that. So they can store everything in Lakehouse. Um, I'll come to the Lakehouse later. Um, so with all these advantages, so we'll use the Fabric. Most of the companies, like mostly 10 plus K organizations are using this Fabric now. So and also it will reduce the uh, disconnectivity of the data. It can also uh, deal with the live streaming data. You guys are aware of live streaming data? Live streaming data is like uh, yeah, stocks, and then if you guys remember when we are going and then we saw some petrol bunks or something like that, there will be some devices, right? So they have some devices, and then they will have the numbers, something like that, this density and how much the liter per hour, I mean per price, like that. So, and those are called IoT things, IoT, Internet of Things. So from that also we can extract data. Those things are called uh, those are called live streaming data. So we can extract batch wise data and live streaming data, and then we can schedule the pipelines according to the data with batch size, or if it is live streaming data, we can schedule the pipelines every hourly, daily, weekly, or something like that. Depends on the batch size. Same thing applicable for incremental data as well. Uh, so and then core components of Fabric. So firstly, we'll talk about the workspace. I mentioned here, but we'll talk about the workspace. In workspace is nothing but um, it will be like a folder, main folder. So you can create subfolders in it, and then you can create whatever, like lake house, warehouse, something like that. Uh, so coming to the one lake is nothing but uh, the data storage which is inside the Fabric. So everything you store, like whatever the data pipelines you build, or whatever the notebooks you written, which is scripts, and whatever the data you have, which you load it into lakehouse or warehouse. So those all comes under this one lake and stored in one lake. That is called one lake, which is Delta Lake. Sometimes it is similar to the Azure Delta Lake. Um, and then coming to the data pipelines, you might maybe you guys are handling some projects, internal projects. Maybe you guys are doing some Python scripts, you are coding some scripts and extracting data. I'm thinking about it. But uh, if you're doing that from, let's say you are connecting to the SQL server and then extracting data from that using Python script or something like that. So those are called pipelines. In Fabric, we have data pipelines. Similarly, in Azure, we call them as Azure Data Factory. Those are a bit similar, but not same. Uh, they have advantages in that and disadvantages as well. Fabric is much easier to learn than the Azure. And coming to the lake house and warehouse, lake house and warehouse are a part of one lake. So lake house is like we can store structured, semi-structured, and uh, unstructured data, which is you guys aware of structured, unstructured, and semi-structured data. So unstructured data is like mm, so plain txt files, text based files, or PDFs, something like that, or sometimes maybe images. uh, Semi-structured data is like JSON format files or HTML. HTML is not structure, I guess. XML. Yeah. XML is similar to HTML, right?
Yes.
So structured is like table formats, which is CSV files or Parquet files. So some kind of formats, Excel, something like that, or tables. So we can store files in the lakehouse as well as tables in the lakehouse. So coming to warehouse, we can only store structured data, which is in table form. So we can't store files as well. We can only store the data in table formats, which is like we can use the scripts and then transform the data. If it is semi-structured, we can, let's say, if it is in JSON format, we'll use the Python scripts or PySpark. Both are similar. So we can use scripts and then we can transform the JSON into table format, or we can normalize the JSON into table format, and then we can load it into uh, lakehouse or warehouse. That we can load it into warehouse as well. But it is bit different than loading it into lakehouse. So warehouse is that we can only store the structured data, which is in table formats. We can't store the files and PDFs or JSON formats. We can store the JSON, but it will store it only in one column or two columns like that. But that is not structured data. And coming to notebooks, it is similarly Jupyter notebooks. I think you can use PySpark in Jupyter notebook, right? No, we can use this. We can use. We can use. It is bit like you guys use Colab, Google Colab. Yeah, similarly this notebook as well. But we only use mostly we can also use Python, and we can also use PySpark. Um, there is environments. So if you create an Python environment, you can use Python related stuff like PySpark and Python and Spark SQL queries and T-SQL queries was there, which is related to warehouse. But you can only run those queries, not the Python scripts, something like that. And you can also, using the notebooks, you can also extract data and then transform. You aware of ETL, extract, transform, load, or ELT, extract, load, and transform. So this is like a data engineering thing. So we used to do every day that, which is like extracting data from source and then transforming the data or loading the data into the destination, and then again doing some transformations or performing some data manipulation things on the data, and then preparing the data ready to the dashboards or for the BIT. So using these scripts, we do such kind of transformations and extraction, and we can also do the machine learning models as well. We can predict the future forecasting. You guys aware of future forecasting, like time series analysis? Yeah. So we can also build ML models, and also we can build some chatbots as well. So I'll come later on that chatbot or something like that. So coming to the data architecture flow. So can you name a few of the data sources that you guys know, except web applications? Huh? That is data, not a data source. Here, data comes from data source. Data is different, data source is different. Sometimes people call the data uh, as data source, but that's not good. But sometimes people used to call that. If you have the raw data, so people used to call that as data source, but that is not the data source. Data source is like if you're if you have a data in web applications or uh, SFTP or warehouses, I mean databases, which is SQL Server or um, SFTP I mentioned. Yeah, cloud storage is blob is comes under the cloud storage. Yeah, in cloud storages. So those are called data sources. So you can also know about the Kafka and some other data sources was there. Those are data storage things. And Snowflake, this is also a database. Uh, these are called data sources. They the organization can store the data in those data sources, which is like applications, web applications, and they can also build apps and then they can integrate the data to the databases. So they can in that situation they'll use some databases which is like Azure SQL databases or uh, AWS S3 buckets and a blob storage and the SQL Server and some other few databases were there, Snowflake, something like that. And we'll extract the data from there and we'll transform or we'll load it into lake houses. Let's say if you have an application, so they have only CSV files in it. So we need to download the data instead of extracting. So they don't have an APIs, or we can't able to do an web scraping. So web scraping is bit difficult than the downloading files. So if you do downloading, then you can get the data easily. Web scraping is a bit difficult than this. Yeah, uh, time taken, and sometimes you might get the incorrect data as well. Yeah, inconsistent data as well, and the data order will be changed sometimes. So those things will be needs to taken care. And then, so if you have an Excel files in an application and you need to extract the data, so you will extract the data using Python scripts or PySpark, both are same. You can use this notebooks using Python or PySpark. So you can connect to that web application if they have any user ID, something like that. So you can download that file and then you can store it into a temporary storage in the Fabric, uh, and we can load it into a lakehouse. Let's say if you have Excel files or CSV files, so you can load them into lakehouse files, and then we can, if we need to do transformations or we need to prepare a data for the further steps or to prepare some dashboards or insights. So we need to store the data into some different layers, which is like first we'll store it into lakehouse files, which is a raw data, and then we'll perform transformations upon that data, and then we'll store it into in a different layer or table formats, and then we'll again do transformations or we'll aggregate the data, depends on the data relations between two different files or um, to different tables. Let's say if you have um, let's say if you have an institute data, so we have students data and then faculty data we have. So how we relate the data is like based on the subjects or classes they were taking. So let's say if I'm taking this class fabric and then students are attending this class, so we can relate in that way, and then we can do aggregation between those two tables, the faculty table and then students table, and then we'll build a aggregated table upon that. We'll build only a single table upon those two tables, and then we can use those aggregation tables, and we can build an insights upon that data using Power BI in Fabric. And also, let's say um, some of the institutes might calculate the student strengths as well. So this year, this many students were joined, and so for upcoming year, how do we need to plan to get more strength? So those are called time series analysis and forecasting. So based on some few parameters, based on faculty how they teach, and based on the environment like classrooms and stuff, and um, faculty interaction communication, and the previous history of the institutes, like how many people are getting placed in the companies, and how many people are well settled in their career. And they used to have referrals, which is like if I joined this year, so they might ask students to refer some other students to have in the institute, and then something like that. So these are all the parameters we consider, and then we'll analysis the data using ML models, and then we'll build some time series analysis, and then we'll get the data, and we'll forecast for the upcoming year or upcoming month or upcoming quarter, something like that. And then, so if the graph is in a peak stage, so then that is fine. So if it is not fine, so we need to adjust these parameters, like faculty teaching, and then this environment, and then the communication between students and the faculty, and then the referrals. They need to market the institute as well. They need to get into marketing, like they need to give advertisements or pamphlets, something like that. Those are called marketing things. So these things we need to consider. So by doing these things, they will think like the people might join. uh, Sometimes it works, sometimes it not, but that is the marketing strategy they usually all the organizations and companies will follow. And uh, coming to the time series, if the graph is peak in stage, then it's fine. If it is not, we'll consider these parameters, and then we'll build some time series analysis, and then we'll replicate this data into Power BI, and then we will showcase to the uh, board members or something like that of the organization or some institutes or the companies, something like that. So this is this is the architecture flow of the data flowing from a data source to the uh, Power BI reports or visualization or insights. And coming to the real time uh, analytics, which is like I've taken the real retail analytics, which is let's say we'll take the example of Swiggy or in Reliance Smart. So those are retail companies. So they have some transactions applications, which we call POS systems, point of sales. So those are called point of sales. So let's say if someone is purchasing something, so they will give a bill. So those things, like they will have the unit prices and quantity prices individual, and then they will calculate upon the quantity with that unit price, and then they will have that data into some system data sources like Azure or something like that, Azure blobs or AWS S3 buckets, something like that. So those will be in data sources, and they from there we will extract the data and then store it into a lake house, and then we will analyze. Okay, this month, from this store, how many orders got placed, or from Swiggy, Instamart, from this month, for this particular area, how many orders got placed, or for this time period, how many orders got placed, and how much the income we earn. And based upon the data, we can analyze the data, which is like mostly they will analyze, and then they will find the patterns like so this let's say this is high tech city area, right? So in this area, mostly the apartments or buildings, they'll give for um, huge prices, like rental houses, they'll give for huge prices. So depending on this area, they were increasing prices. So when we comparing to the outskirts of the city, so they'll give less price than here. So we need to consider those patterns as well. Those are called patterns finding in the data. So we'll find the patterns, and then we'll analyze the data, and then we'll come up with a strategy, and then um, we'll implement this strategy, and then we'll get uh, like the maybe sometimes they will give some discounts for Swiggy, Zomato, or in retail companies. So based on that, they will get more profits. So these are called marketing strategies they'll use to play in every time. So to increase their sales, and then will they will also monitor the data, and using this they also have some BI team. They were um, they were having uh, the data visualizations, and then they will prepare some dashboards based on the data, how much we earned this month, and then how much we need to uh, in the next month, and then they will give targets to the stores, and then so they will if we need to increase the sales, they also need to take care of few things like um, giving discounts or um, offers like buy one get one, or if you pay bill for 1,000 rupees, they will get 1 kg of sugar, something like that. So if they will play these kind of things, tactics, and then they will get profits in the sales, and then they will gain more customers as well. So this is real time retail analytics from this fabric. We me too. And then so actually in one lake the data will be stored in file format, right? So it seems to be in file format, but in the backend, if you see, the data will be stored in Parquet files. It's slightly similar to CSV on the Excel file form, which is in table formats. And also, OneLake is the main thing for Fabric. So that all the pipelines, all the data which you have stored in Lakehouse, warehouse, or in the temporary storage that stores that should comes under this OneLake. And we go navigate to the so this is how the fabric look like. So we have uh, workspaces. These are called workspaces. You can also create one. So currently I am using a free trial one. So I just give a name. So just now we have created a fabric workspace. So we need to select a free trial if you don't have any fabric license. So later on, I will tell how you need to create a free fabric free trial account. And then this is the free trial fabric capacities, which is like processors. So if we need to run some Python code or something like that, so we need processors, right? So this fabric capacity is similar to that CPU, which is like we have cores in our system, right? We'll have some cores, right? We'll have 8 cores in our system, laptop, PC. So in Fabric, it starts from 2. So we'll have 2 cores, 8, 60, 32, and 64, and so on. So depends on that course, the pricing will be increased. So currently we have a Fabric free trial, so that's not chargeable. So we'll have a 60 days of free trial. So I started this yesterday, so it is showing me 59 days left. So by default, we have this many fabric capacities, so we can select any one among of those. So and then we can click on apply. So it will take a few seconds to do. I think the fabric workspace got created. If you see here, the workspace is created. Yeah, this is our workspace. So if you see here, we have add folder. Let me, yeah, I- source. So these are the folders we can create, and we can have an items. So earlier I mentioned the notebooks, warehouse, and then data pipelines, right? And we have also data flows into, which is like similarly, instead of writing scripts, we can also use this data zen 2. uh, it 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 can connect to various data sources, and then we can write Power Query. You might heard in Excel also we can do Power Query, right? And in Power BI also they used to do Power Queries. So we can use that Power Queries, and then we can extract the data, and then we can transform using that Power Query, and then we can load the data into a warehouse or lakehouse as wherever we need. And then we have notebooks pipelines, and we have many of them. And then we can also see Snowflake, mirror Snowflake, and mirrored SQL Server, Cosmos database, and then Lakehouse. So let me create a Lakehouse. Let's say we create speech. This will stores under the demo one workspace. If you need to create another in another workspace, you can also select like this, which is this is a schema based, which like DBO, or you can create something like depends on data. You can also create like institutional schemas, something like that. This is schema, which is DBO. By default, it will create a DBO schema. So here, if you see, we'll have a storage for files and then the tables. So currently this is new, so it is empty. So let me quickly create version notebook. So this is notebook. So here you can uh, use Python, Spark Scale, and Spark SQL, or Spark R, or HTML code as well. But I I am not worked with those things, but I am aware of this PySpark and Python. So let me quickly grab creating data. So this is the code to generate some random data. So if you see, we have the lakehouse here, which is some tables and the files. So currently, I'm gonna load this random generated data into the files. Okay, so we'll mm, so this is department. So let's see how the data is first. So if you click on this run or run symbol, or if you click on shift enter or control enter, it will execute, and then it will. So in Python we'll use print, right? In Python and maybe in .NET as well, we'll use print. We can also use print here, but display is way more good looking than the print. So if you see, if we used display, right? So upon that data frame, we use display, which I have taken only 10 records. So this is in table format. So this looks good. Like how we used to see the data in the wherever, like MySQL Workbench. If you guys query something, select star from some so on so tables, and some of the mm, SQL Server databases or something like this is in table format, structured format. So we can directly load it into Azure. So this got loaded into this files. Let me refresh this. So if you see here, the data is loaded into this files. So actually, you can just drag this file and then place it here in the cell. So you can get the read script automatically, and then we can get the data. I mean, we can visualize the data as well. So this is how we used to load the data into Lakehouse files. So currently, I have generated this file, I mean data. So, but you can use the data sources or any other APIs if you have. So you can use those and then get the data from those APIs or SQL Server, something like that, and then load it into Lakehouse files. So before loading into Lakehouse files or Lakehouse tables, so you need to convert the data frame to the Spark data frame. So if you are using Python or PySpark, so you might uh, don't notice the difference between Python and PySpark. So there are similar scripts, I mean syntaxes, some syntax, and then some libraries might not work in PySpark. Some libraries might not work in Python. So there is a difference. So which is like if you write a, I mean, if you read a CSV file and then store it into data frame, that is a pandas data frame, right? So if you use Python, that is pandas data. If you use PySpark, that comes under Spark data frame. So if the data frame is not Spark data frame, we can't load the data into our Lakehouse or warehouse. In Lakehouse, we can't load in files or in tables as well. So so we need to convert that data frame into, I mean, if you are reading CSV file in pandas data frame, we need to convert that pandas data frame into Spark data frame, and then we need to load it into Lakehouse in files or tables. So now I am going to load this into Lakehouse tables. the data. This is like uh, city and sales. This is some data. Performance. We'll have better. So, so this is the file path, which is we need to give. This is our file path, right? And we'll use this file path and then read this. Yes. CSV file. So if you see here, the file stored in CSV, but in the backend, you can see it's stored in Parquet. Not Parquet. It will partition the data into chunks and then it will load it into the different CSV files or different Excel files. And we read this file and load this into a table. So this is the file path, and then this just will displays the data, and then we'll loading it into organization department table. Let me run this script. So if we don't give any schema name, it will automatically takes the DBO schema name. So this is the way how we load the um, Lakehouse files into Lakehouse tables. And let me show you the table name as well. If you go to here, it comes under the DBO schema. You can also drag this and then, so you can see here, this is our Lakehouse name, and this is our schema name, and then this is our table. This is how we can get uh, the SQL script if you drag and drop this table name into in a cell, and then we can get data. We can read the data from that query, Spark SQL query. So this is how we can load the data into Lakehouse from auto generated, or if you have any CSV files, you can also directly upload it into upload upload files. You can directly browse the local files and then uh, directly upload. Click on upload, then it will upload, and you can see the data here, whatever you have upload, and then you can migrate the data to tables. Now we'll create a warehouse. Say organization data. So So here the warehouse got created. If you see, this is our warehouse. So in this we'll have schemas and then securities, and then we can also go through the previous runs of our queries and then shared queries among the team members or colleagues. So this is our tables, but we'll see nothing here. And so if you need to migrate data from lakehouse to warehouse, so we need to build a data pipeline. So directly we can't move data from lakehouse to warehouse. So so to do that, we'll build a data pipeline, which is, you click on new item, we can have pipeline here. This is called a data pipeline. Data pipeline, let it be. So this is how the data pipeline looks before any pipelines created. So these are all the activities we can perform, which is like script. Like we can run the script in warehouse or the lakehouse. But using these scripts, also we can load the data from lakehouse to warehouse. Also, we can have different activities to load data from lakehouse to warehouse. So, so we'll go to one lake catalog. So we have a warehouse here. So scripts only works on warehouse, not on lakehouse. But few of them works on lakehouse as well. Uh, let's say lookup activity. Lookup activity is like hmm, just reading of the data, and then we can use that output in further activities as well. We delete this. So let's say you have this activity, right? So in this we can use this query, like this is our table. So this is our table, right? So I will just copy this and then paste it here. So so this is in lakehouse. So let's say you can use select star into. Let's say if you need to load the data into dbo schema in the warehouse, so you need to give dbo dot the rest of the table name goes. Or if you need to give some other schema names, you can directly give here. It will automatically create schema. So if you run this, the data will be stored, automatically migrated from lakehouse to warehouse. Click on OK. So this script is like migrating data from lakehouse to warehouse. So for that, I have used a simple query, which is you all know select star from table name. So I just used this insert into like table name. So this will insert the data into warehouse, which is in DBO schema. So it's gonna create a new table in warehouse currently I'm seeing nothing in warehouse, right? So once I run this script, or once I run this pipeline, so it will automatically migrate the data from lakehouse to warehouse. So let me save this pipeline, and the pipeline got saved. I'm running the pipeline now. So here we can also monitor the pipeline, and we can also get the logs from the scripts, like if we got failed. So we can also have monitoring. So we have one. So currently this pipeline is not started because of that. Pipeline needs to be assigned to some of the jobs. So if you click on this, you can monitor the pipeline, how it is running. You can't edit here. So if you need to edit, we need to just click on update pipeline, then you can able to edit it. So this has got success. If you can see here, we have input and then output. So input is like the query which we written in that SQL script, and then output is like how many records it got loaded, and what are the parameters if we have something like that. And let me show you the table which we created. This is the table which we created just now. So this is the data from the warehouse. This is the warehouse table data, and then this we can also check the data in Lakehouse as well. If you need to check the data in Lakehouse, you need to query in this way and then um, view the data. So if it is warehouse, we can just query like this, and we can also query the Lakehouse SQL endpoint. So this is SQL endpoint. So here you can query the table. No SQL query. So this is actually the destination lakehouse which we created. It might look like similar to the warehouse, but it's not, because we can also store the files in lakehouse, but we can't store the files in warehouse. And we can migrate the data from lakehouse to warehouse using this pipelines, or we can, this is one of the activity we can use. I'm just deactivating it. Even now if you run this pipeline, it won't execute, it will just pause, it will just skip this activity. So I'll just add one more activity here, how we can migrate data from warehouse to lakehouse. Let me, so I'm just dropping this table to migrate again using different method. So the table got dropped. So we'll use the copy data activity, which is like we can select the source and then we can migrate the data to the destination. So here our source is the lake house. So we can select in the one lake catalog. But using scripts, we can't select that lake house. But here we can select the lake house in copy data activity. This is table. We can also migrate the files, but we'll try the tables now. Only one table left, right? So this is the table. We can also preview the data, what the data is present in that table. So this is the data which we have, right? So we'll just select the destination here, which is the warehouse from one lake catalog. So this is our warehouse, right? We'll select this, and then so using existing table, or we need to create a new table. So currently we have deleted that table, right? So we'll use auto create table. Schema is like DBO or whatever we can mention. That is our. So table name is this. So insert and upsert. Do you guys know what is meant by insert and upsert? So insert is like loading entire data or loading some of the data into certain table or files. So upsert is like this is also loading, but upsert works in different way. So upsert is like updating data or inserting. If the data matches based on the primary key on or certain IDs, fields, something like that. So we'll update those records. If that doesn't matches to the source data, we'll insert the records. That is called upsert. Update plus insert is called upsert. If the data matches, we'll do update. If it doesn't matches to the source, we'll insert the data. That is called upsert. And we can have a pre-copy script, which is like let's say if the table already existed in the warehouse, so we can just type like drop table dbo dot table. So by using this command, we can drop the table. If it doesn't exist, it will throw an error. Instead of that, we'll use delete from, which will delete the data from that table, entire data from the table. So we can use this kind of scripts, or let's say if you are migrating the data incrementally, like let's say if you have data in day wise. So let's say if you have 2 days data, and then you get the data tomorrow. So you already have the data in the warehouse, which is yesterday's data, and you can delete the entire data, or you can only delete those data in warehouse, and then load the new data into the warehouse by using some kind of commands. Like if you have date columns, or based on the ID columns, we can use where conditions, where date equal to uh, like get date minus 1, which is like get date is get date will give the current date, and then minus 1 is like yesterday's data. So we can delete the yesterday's entire data, and then we can load the new data. It might be incremental, or it might be full load, or historical load data, something like that. So So we can use this pre-copy script, but we deleted the table. So I'm gonna give to create and insert. So I'm not gonna use this pre-copy script, and then I'll save this pipeline. Whenever you do changes, you need to save it, and then I'll run this. So you can see the input and output and which script, I mean, which activities it is running. So in input, we'll have lakehouse table source as a source, and then the lakehouse name and the workspace ID and the table. We selected the table format, right? It's table, and then we have files. So we selected table. So it is table, root folder is table, and then the schema is dbo, and the table name is db organization departments, and it will auto creates whatever the parameters we have chosen in this activity field. So it will show those fields, which is like table name and lakehouse connection names and the destination. Let me check. So it got executed. So let me check in the output. So we have 31189 records, and the return data is this much. Read it files is 8, which is like I've if the data is in lakehouse, it will read the data into partition wise, and then it will load it into warehouse in partition wise. Let's say if we have 100 records, it will read the data in 10 chunks, and then 10, 10, 10, 10, 10 like that, and then it will load it into warehouse in the same way. So using parallel processing, something like that, or threading. This is the output. Oh, so let me go to the warehouse. If just refreshing this. So see, you can see the table here, and we'll just this select script again. So in these ways, we can get the data from lakehouse to warehouse. So so we have other methods as well, like we can create data flow. So I think in Fabric, we can create a data flow first. So we found a new item, so we can create data flows into, but it costs more than our data pipelines. Data flows into costs more than our data pipelines, which is like if I am migrating one table from warehouse to lakehouse to warehouse or warehouse to lakehouse, it will take at least $0.25 per run. So that's why we'll in cost effective management we'll use this data pipelines instead of data flow. But for the sake of learning, I'm just showing you how we can connect to the. So we can add the data source, which is lakehouse. So connection is this. Click on next. So this is a lake house. This. We'll want to choose this destination. Our lake house. We'll select this as a data source, and then we'll try to load the data from lakehouse to warehouse. So let me pick the table and create. So this is called a Power Query. You can also see this. So change the settings. So this is destination. We'll add the destination as our warehouse. This is our warehouse. DB or schema. If it is existing table, we can just directly select this table here. So now I'm gonna delete that table here, and then I will create it again using this data flow activity. So if you see here, the table is gone. So we'll use this data flow to create new table using this table name. Refresh. Select. Click on next after giving the table name. So let's say if the table columns needs to be replaced, or table columns, if we have any spaces between the columns, like in the column names, so we can just use the Power Query to replace them. And These are all the columns we have in that. So we'll just have the text data types. We'll just save the settings. So the data warehouse got added. So the source is like lakehouse, which we created. The destination is like warehouse, the organization warehouse. So now if I save this, so it will save. We will only save it. Even if you save this, the table automatically got load into this warehouse, because it will read the data and then directly connects to the warehouse, and then it will directly migrate the data from lakehouse to this warehouse. So Yep. We use this data flow here. I'm gonna deactivate this. So coming to this data flow settings, we'll just go to settings, and then this is our workspace, and in that workspace we have only one data flow, which is data flow 1. So if we save and run the pipeline, it will automatically migrates the data from warehouse to lakehouse to the warehouse. Currently we can't see the table in this, right? So we don't have the table in warehouse. So after running this pipeline, we'll see how it got loaded. So coming to inputs, we'll just give that fabric workspace ID and then the data flow ID, but we given name it back in backend, it will take the ID. For data flow, it will take more time to load the data from, because it needs to connect the lakehouse and then it needs to extract the data, and we have a few small kind of transformations as well, and we'll this is called refresh. Okay. The table got executed. So let me refresh the schema. Updated, refreshed. this refreshing here. The data flow is got refreshed. It will take some time. Sometimes it will take time to refresh in the warehouse. But if you see here, the data got loaded into uh, the destination, which is from warehouse to warehouse to warehouse. The rows written is 99. It was successful. Yes. That's why people don't use this data flows. Sometimes it works weird. So it will take some time to refresh in warehouse. So these are the methods how we can migrate the data from lakehouse to warehouse, or we can also migrate the data from warehouse to warehouse or lakehouse to lakehouse. Like we can create a new tables in the lakehouse itself uh, by performing some transformations or by uh, adding some insights to the data, something like that. So this is how the fabric pipelines looks like, and we have a few more activities here. You can see copy data, we have used it, data flow we have, and notebook. Coming to notebook, if you need to schedule a pipeline, like you have a script, and then you need in that you will extract the data from source to the uh, source CSV files, or web scraping, or in using the SQL Server databases. So you can extract using that scripts, and then you can add them in the data pipeline. So let's say we can also connect like this. I will add notebook which we created, notebook one, and then if you say one execute this pipeline, this notebook will run. So we can, so in that, let's say we'll do we are loading it into a lakehouse, right? So we'll load it into lakehouse, and then we'll just remove this part as well. So up to lakehouse we are loading. So this pipeline, what it will do is, so if I add this activity, just we can connect them and then run the flows. After this notebook execution is done, then this uh, lakehouse to warehouse migration will be uh, queued, and then it will migrate the data from lakehouse to warehouse. And we can also use different methods. Instead of this copy data activity, we can also use the scripts as well by connecting this. And if the pipeline fails, what do we do is, so we can have a notifications like Outlook, emails, or your Gmail IDs, something like that. So in this, what do we do is we'll connect with the email ID here, which is our email ID, and then these are the this is like you need to mention the um, to which you are going to send the email, like the email IDs of the clients or something like that. And this is the email body. This is email body we need to write here, and this is the subject. I mean like uh, alert notification. So we'll use this kind of subjects, or maybe we'll use the data source names, and then let's say uh, organization data pipeline uh, status. Like if it fails, like we'll have that as the data pipeline got failed in this, something like that. Hi, something like that. Hi, hi. Uh, Organization data pipeline. So, and then we can give out something like regards. So this is how we used to write the emails using our Gmail account, through Gmail account or Outlook. In the same way, we can write here. I mean, what do we need to notify the people, and we'll connect this to failure part. We need for the failure, right? So if the pipeline fails, we'll get a notification that the pipeline failed because of so and so reason. So we can also get the previous outputs, activities outputs here. You can see the scripts outputs, something like that. It will give the scripts outputs, and then we can use that as our let's say information to the client, how we can showcase them in via emails, but they can't go and query the data and then see, right? So in this way we can showcase the data to the clients or to the people whoever we need. So this is the data pipeline of Fabric. Y- you guys have any questions on lake house, on Fabric, warehouse? How does the data flows? So I think you guys are good. So this is just a small example, but maybe in future you can deal with huge data, and you can write more complex data pipelines, I hope. I think that's all today. Thank you guys for being patient, listening. Yeah, if you have any questions, you can reach out to me regarding Fabric, Python, SQL. Of course, you guys have your faculty for Python and stuff. You guys have any questions? You can ask. Don't think like it's been a silly questions, something like that. You can ask any questions, no matter what other things. You might get confused at the starting day, missing new things. So you can habituate these things going forward. And also, I forgot one thing. You can also schedule the pipeline. You can add schedule. It is by minutes or intervals. Like I've told you, like the live data or streaming data. So we can use this repeated intervals by minute or per hour. We can have per hour also, hourly, daily, weekly, and monthly. And we can schedule the time, start time, and time. For by minute, I think we don't have a scheduled time. For hourly, also we don't have. For daily, we have. So daily we have the time. So when did the pipeline needs to be run? This is the timing we need to opt, and then we can just run to 2 p.m. every day. And we can this the start time date. We can select the time zone as well. And this Chennai, Kolkata, something, and then we can save it. So without your intervention, it will run every day at 2 p.m., which is in 1 hour 15 minutes. So you can also add another schedule and daily for another time as well, 7 p.m. Say, so now the pipeline runs twice a day at 2 p.m. once and then 7 p.m. at once. So after this, you need to save this. So yeah, I didn't give the credentials. So now it will execute every day on these schedules without your intervention if the fabric capacity is on. Of course, we are using the free trial. It will be on every time. So it will run every day at 2 p.m. and 7 p.m. So this is how we used to schedule the pipelines in our fabric. So you can just write the code once and then uh, create these pipelines by selecting notebooks and this using this copy data activity and some other activities. If based upon the requirements, we can use those activities, and then we can schedule this pipeline whenever we need it, or daily, weekly, monthly, something like that. And then it will execute daily or depends upon the frequency. Frequency is nothing but daily, weekly, monthly. So that's all I have to read.
You give the example of the Reliance Retail.
Yeah.
How do I see this flow in that example?
So actually, they have some backend databases, right?
So you said pause, people enter the details. That's on database they created.
Yeah, they have some application, web applications. So let's say for Swiggy, that is retail company. So if you order something, so backend they will store the data in somewhere, or databases or something, CSV files or Google Sheets, something like that. So we can get the credentials of those data source, and then we can add, let's say in copy data activity in source. If I'm deleting this, I can select browser. So we can have n number of data sources. They might shared in SharePoint, datawares, and folders, or SQL Server, SharePoint, and we have many. Wait, you know, uh, Oracle, something, Greenplum databases. So whatever they use, we can just click on those, and then we can give the credentials, and then choose it, whatever the tables they have, and we can select those tables, and then we can migrate the data and analyze the data accordingly, and then we can
We
use.
didn't analyze any data here.
Here we did it, but we don't have credentials, right?
So we stuck at step 1 and 2 only.
I just gave an example so people understand. That's why I've shown the generated data. Anything else?
Blueprint creation.
Huh?
Blueprint creation.
Free trial creation. Actually, we can't create a free trial using our Gmail accounts. So for that, we need to have an organization account, or if you have an Azure account subscription, we can use an Entra ID. Using that, we can create multiple users. So um I'll think. So we need to use the um, email ID and stuff. We'll use this. Enter the password. This is an organization email ID. That's why we can directly jump into here. So we can directly create, I mean, log into Fabric. But this free trial not started yet. You can see previously I have deleted that free trial. I mean, canceled the free trial. Now I'm going to show you after logging in how we can start the free trial. So if you go on profile, you can see the start free trial here. You can activate. So you can also select this, or that is not an important thing. You can just select the random one, and then you click on OK. This is like you can invite your teammates, like colleagues or teammates. I'm just skipping it. Now that retail got created. So if you see, that got vanished. Pure Power BI, Fabric and Power BI trial status, 59 days. You can cancel whenever you need. Maybe you can extend the free trial also. I'm not sure about it. Previously they don't, but now they were. So, but we can't create a Fabric free trial without organization email. We need organization. You guys,
This Power BI.
this is we can use many, like Fabric, data engineering, and data analysis, ML models creation and analyzing data, and also we can build reports as well. So currently we are in Fabric, which is like data analysis and uh, extraction. We can also go to Power BI. I think for this we need a pro license if we need to publish the dashboard into cloud. But we can create dashboards. Let's see. So these are the previously created one. So this is how the dashboards look like in Fabric. Similarly in BI. I know. No. These are created, not 3D. These are visuals and then slicers, cards. I'm a data engineering guy. I don't know much about Power. Well, yeah. Uh, that's all, guys. Do you guys have any questions, concerns? Am I going too slow, too fast?
Mind is going slow.
My
Going fine.
my mind is going.
My mind is often going slow.
Yeah, because when you listen new things, you might stuck at the first time. You will learn with hands-on practice.
So what is the alternate of Fabric?
You can use Azure Synapse Analytics, but in that you need to use two different tools: Synapse Analytics and then Data Factory. So in Synapse Analytics, we can build pipelines as well, and we can run the notebooks as well. Similarly in this Fabric, but we can't use this BA.
This is the only option.
Yeah.
Which is having
Yeah.
both.
Both. Not only both, we have storage as well. Storage, extraction, analyzing, and visualization, reporting, everything. Unified data platform.
Unified data.
Yeah, you. So if you guys didn't understand anywhere, you can ask me. Looks like everyone. Yeah. Okay. Online also. Yeah, yeah. My bad. I hope online people also understanding everything. If you guys have any questions, concerns, you can ask me here. No, no, one. Only one. Only one participant. Okay.